we are going to find the inverse of f of x equals square root of x plus 4. We're going to graph the original function and its inverse on the same coordinate plane. Let's actually start with that. So let's plot the original function, and we will start by, well, doing what we know to do. This is a square root function. It is shifted to the left 4. This plus 4 is with the x. You could say it's in parentheses. It's under the grouping symbol, so to speak, air quotes there, of the radical. So we're going to go negative 4, 1, 2, 3, 4, and put a point at 0. Now, we also know this because if we plugged in a negative 4, we'd have negative 4 plus 4, that's 0. The square root of 0 is 0. So plugging in a negative 4 is going to give us an output of 0. Plugging in a negative 3 is going to give us an output of 1. And here's why. Plug in a negative 3 plus 4 is 1. The square root of 1 is, well, 1. Okay? Plug in a negative 2, you're going to end up with the square root of 2. That's 1.4-ish. We don't want to play that game. Same thing with negative 1. You're going to end up with the square root of 3. That's nice, but no. Let's plug in a 0. If you plug in a 0, you have the square root of 4, which is 2. And then we'll do one more. If you plug in a 5, we're doing this strategically. If you plug in a 5, you'll have 5 plus 4, which is 9. The square root of 5, 1, 2, 3, 4, 5 is 3. So we're going to have a square root function. It starts here, and we're going to make this as neat as we possibly can. That is probably the best square root function I have ever freehanded. There we go. Wonderful, wonderful. We're also going to graph the inverse, but let's find the inverse first. So why don't we do that thing we do where we switch x and y and then solve for y. So currently this is y, so if you want to waste a step, you could say y equals square root of x plus 4. And then you're going to switch x and y. So x equals square root of y plus 4. Okay, cool. Now we're going to solve this for y, and you might be tempted to subtract 4. You can't do it yet. It's under the radical. So instead, let's undo a square root, and we will undo the square root by squaring this side and squaring this side. That means that we have x squared equals y plus 4. And then we're going to subtract 4 from both sides. So we're going to have x squared minus 4, and that's equal to y. And that's fine. That's fantastic. It's wonderful. I like it. It's correct-ish. There's some stuff we need to do to it to make it truly correct. But in terms of notation, we will go there first. That's going to be f inverse equals x squared minus 4. Now, let's start graphing this. This is a parabola that is shifted down 4. So we have graphed parabolas before, and normally they would be at the origin. I'm trying to get that just right. But this one's going to be shifted down 4. So for those of you hardcore mathematicians that are watching this video, and you're like, he just lied to his students. Yeah, hang with me, okay? If we plugged in a 0, 1, 2, 3, 4, we'd get negative 4. If we plugged in a 1, we would get negative 3. If we plugged in 2, we would get 0. And if we plugged in a 3, we would have 5. Now, I hope you're starting to notice something here that you might have already noticed on the previous 2 problems that were linear. I'm going to go ahead and connect these right here. And we're going to have half of a parabola. Now, a second ago, I was talking about this graph, and I said, oh, look, it looks like this. And we'd shift it down 4. It doesn't look like this. It's like this. It's only half a parabola. So we don't have the whole thing. We have just one piece of it. How come? I'm glad you asked. This is going to lead us to the next video in a few minutes about observations of inverses, but I'm going to go ahead and say one of them right here. When you switch x and y, you reverse the coordinates. And so when I had negative 4, 0 on the original graph, I'm going to have 0, negative 4 on the graph of its inverse. When I had 0, 2 on the graph of the original function, I'm going to have 2, 0 on the graph of its inverse. So to truly graph this parabola the way it would be intended to be graphed means that I would also graph back here. And if I graph back here, and I'm going to just grab a scrap piece of paper for a second, it has some writing on the back side of it. You can ignore that. And if I truly graphed that parabola, it would look like this, okay? If I graphed it as the parabola that it maybe should be, or we would like to think it is, then the original function, well, the original function was like this, which means to truly reverse the coordinates, we would also have this down here. And I didn't draw everything perfectly right into scale, but it would look like that. Okay, we'll look at the blue function. it's not a function. I was wrong to even call it a function right there. This is not a function whatsoever because for any input, 0 for example, you'd get this output and that output, and that's not truly a function. So we have a situation where the inverse needs to match the original function. And so we're going to have to chop part of it off. So again, notice that this piece of the graph, the red piece, is over here on the positive side. It's not here on the negative side because that's what corresponds to what we already had. So this graph, x squared minus 4, would be both legs of the parabola. I don't want both legs of the parabola. I only want one. I only want the side of the parabola, that is, let's put a comma, greater than or equal to 0. I only want this stuff from here over. I don't need the stuff back here. So what I've just done is restrict the domain. Speaking of domain, let's find the domain and the range. Domain, range. Here we go. We're going to have our original function, and we're also going to have our inverse. There we go. Okay, let's write a few things down. Let's just deal with the original function, which was blue. So original function had a domain from -4 to infinity. -4 to infinity. I just made a mistake. I hope you catch it. I'm about to fix it. Pause the video if you haven't caught my mistake yet. There it goes. All right. The original function has a range from outputs 0 to infinity. So it's going to go from 0 to infinity. There we go. That's it. All right. The inverse function is going to have a domain from 0 to infinity. Now, again, if you graphed the entire parabola, the entire red thing, you'd say -infinity to infinity. That's going to lead us to another observation about inverses in a second. But not really. It's not going to do that. And that observation about inverses that we will articulate in a minute is that I'm going to have to, well, when I switch x and y, not only do I reverse the coordinates, I also swap the domain and the range. So we'll cheat in a minute. Okay, the range on my red inverse is going to be from -4 to 0 to infinity. Let's get this right. -4 to infinity. There we go. And so what I will say in a second ago about cheating is this right here. It is the fact that what I could do is say, well, you know what? I found the domain of my original function. That is the range of my inverse. I found the range of my original function. That's the domain of my inverse. And we'll articulate that in another video. Let's move on to the next problem. And when I do, we will start by, well, let's find the inverse first. So y equals x minus 1. It is squared. We would like to reverse the coordinates. And so x equals y minus 1, and it is squared. Now, I did leave this part out, so let's read it. Find the inverse of this function where x is greater than or equal to 1. Oh, they've already restricted the domain. Good to know. Then they want us to graph and do all that fantastic stuff. So let's just keep moving along here. We're going to take the square root of this. That's going to get rid of the squared. So we're going to have the square root of x, and that's equal to y minus 1. And so then we'll have square root of x and then plus 1, and that's equal to y. So what we really have is the inverse, and is equal to square root of x and then plus 1. Okay, let's graph the original function. And the original function is a parabola that is shifted to the right 1. And we'll graph it in blue. That's how I've been doing my original functions. So original function shifted to the right 1. And it is a standard parabola. So there's a point at 2, 1, and a point at, never mind. I almost went too far. I almost said there is a point at 0, 1. No, there's not. We're only going to graph half this parabola. We're not going to graph both legs. We're just going to graph one leg. Let's plot a, I have a hard time saying it, let's plot a coordinate at 3, plug in a 3, and we're going to get 4. And then plug in a 4, we're going to get a 9. We're off the graph. Okay, so the original graph, before we took the inverse, looked like this half of a parabola. Okay, now we could graph this, or we could use some of the tools that we've already discovered where I could just reverse the coordinates, right? When you switch x and y, that's what you're doing. So 1, 0 becomes 0, 1. Ooh, that's good to know. 2, 1 becomes 1, 2. Okay, there we go. 3, 4 becomes 4, 3. And then we have this square root function right here, which truly does match what we know. We know what a square root function looks like. It's that shape, and this one's shifted up 1, and this parabola corresponds to that, only it's greater than or equal to 1. And just for consistency with what we've done, let's also put these in the corresponding colors. That's what we've been doing so far. If you're not doing this right now, that's totally fine. And what I am going to do is also talk about domain and range, but I'm going to cheat this time. It's okay to do that within the context of what I'm about to say. Let's not truly cheat, but there are some shortcuts that are good to know. And here is your first little shortcut that you already know. So it's not your, actually it's not your first one, it's your second one. Okay, the original function domain, they already told us actually. I mean, look at the graph if you want to, but they already told us it's greater than 1 or equal to 1. So from 1 to infinity, there we go. All right, time to cheat a little bit. I know the domain of my original function, so my range of the inverse corresponds to that. So if you want to draw little arrows and be like, oh look, they are the same, that's fine, you can. The range of the inverse, the range of the original function, the blue one, is going to start at 0 and go up to infinity, so from 0 to infinity. And that would correspond to the domain of the inverse, which makes sense, from 0 to infinity. So from 0 to infinity, there it is, and draw little arrows if you like. That's it. And we have done everything they have asked us to do. There we go.